All right, here's a wild thought for you. Can solid metal just catch fire? It sounds like something straight out of science fiction, right? But believe it or not, it's a very real and very dangerous industrial hazard. We're talking about something called pyrophoric iron fires. Let's dive in. I mean, really think about it. How can a chunk of solid metal suddenly burst into flames? It goes against everything we think we know. Metal is supposed to be tough, stable, the last thing you'd expect to spontaneously combust. And yet, under just the right conditions, that's exactly what can happen. Okay, so picture this scene. A refinery crew is just going about their day, doing some routine maintenance. They go to open up a big steel vessel, and the second the outside air hits the inside of that tank, whoosh, a fire erupts, seemingly from the metal walls themselves. No spark, no lighter, no ignition source. Just air meeting metal. And that's the bizarre mystery we are going to unravel. So, what in the world is going on here? How is this even possible? Well, to figure that out, we've got to unmask the invisible culprit that's lying in wait. And the key to this whole thing is a single word, pyrophoric. It actually comes from the Greek for fire-bearing, which is, how perfect is that? It literally means a material that can just ignite on its own spontaneously just by being exposed to the air. Now, the specific fire-bearing substance we're talking about here is called iron sulfide. And this stuff isn't supposed to be there. It's an unwanted chemical byproduct that builds up as a solid scale, kind of like a chemical version of rust or limescale, on the inside of refinery equipment. So why is this stuff so incredibly reactive? Well, it's fascinating. The iron sulfide doesn't form a smooth layer. It forms these incredibly fine microscopic crystals, and all those tiny crystals add up to a massive surface area. The best way to think about it is like this. You can hold a lighter to a solid steel block all day and nothing's going to happen, right? But if you take that same steel and shred it into steel wool, well, that goes up in a flash. It's the exact same principle here. More surface area means way more contact with oxygen, and that means a much faster, much more violent reaction. Okay, so how does this super dangerous material even get there in the first place? It's not like they're pouring it in. It all comes down to a really interesting two-step chemical reaction. All right, so step one is the quiet part. It happens silently, hidden away inside sealed equipment where there's no oxygen. You've got your basic iron oxide, rust, and it starts to react with hydrogen sulfide gas, which is super common in the oil refining process. This reaction, you can see the formula on screen, it slowly turns that harmless rust into a dormant but super unstable layer of iron sulfide. It's just sitting there, a ticking time bomb. Then comes step two, the trigger. The moment that vessel is opened and air rushes in, bam! All that oxygen hits the iron sulfide and it rapidly oxidizes. Basically, it's turning back into rust, but incredibly fast. And as you can see in the equation, this reaction is what we call exothermic. That means it releases a massive amount of heat. So much heat, in fact, that it's more than enough to ignite any flammable vapors or materials that might be hanging around. And here's another really crucial and, frankly, scary detail. This reaction doesn't just create heat, it can also produce a big cloud of white smoke. And you might look at that and think, oh, it's just harmless steam, but it's not. It's actually toxic sulfur dioxide gas, a huge hidden danger for any crew working nearby. So, knowing what this stuff is and how it forms is one thing, but where exactly do you need to look for it? Where are the real hotspots for this danger inside a massive, complex facility like a refinery? Well, the highest risk zones are pretty much anywhere that these chemical deposits can easily build up over time. We're talking about places like distillation columns, those giant crude oil and asphalt storage tanks, pressure vessels, and especially the internal components, things like trays and packing, because they have all these nooks and crannies with tons of surface area for that nasty iron sulfide scale to form on. And let's be crystal clear, the stakes here could not be higher. This isn't just about some expensive equipment damage. As this quote makes chillingly clear, these fires can be fatal for the people just trying to do their jobs, the inspection and maintenance crews. It is a hidden threat that can turn a totally routine task into a life-or-death situation in the blink of an eye. Wow. Okay, after hearing all that, it might sound like this is some kind of unstoppable freak accident. But it's not at all. So let's shift gears now, away from the problem and toward the solution, because there are very clear established ways to prevent these accidents from ever happening.
And this right here, this is probably the single most important thing to understand. These terrifying incidents are, and I'm quoting here, entirely avoidable. They don't happen because of some random act of chemistry. They happen when the right safety procedures aren't understood, or worse, aren't followed. So, what are those procedures? Well, they really boil down to two simple but absolutely critical goals. Goal number one, get rid of anything that could possibly burn, like leftover oil or gas, right? No fuel, no fire. And goal number two, you have to either completely remove or chemically neutralize those pyrophoric iron sulfide deposits before they ever get a chance to see the open air. And that's achieved through a really meticulous step-by-step decontamination process. It starts with things like steaming and hot water washing to clear out any flammable stuff. Then the equipment is totally isolated. That's called blinding. And only then, once it's clean and safe, do they use special chemical treatments to neutralize the iron sulfide, basically rendering it harmless before anyone opens that hatch. It's a system that leaves absolutely nothing to chance. All right, let's pull all of this together and do a quick recap of what we've learned about this pretty incredible hidden hazard. So, we've seen how something as ordinary as rust can transform into a hidden fire-starting chemical inside an oxygen-free environment. We've learned that this dormant threat is just waiting for one thing, a little bit of air to ignite instantly. And most importantly, we've seen that while this danger is very real and very serious, following meticulous, well-established procedures is the absolute key to preventing a potential disaster. You know, it's a powerful reminder that sometimes the biggest dangers aren't the obvious ones. They're the ones we can't see, born from simple chemical reactions just hiding in plain sight. It really makes you wonder, doesn't it? What other hidden dangers are we overlooking in our world? Just waiting for the right, or maybe the wrong, conditions to reveal themselves.